While we've all had our eyes glued to AI, there's another revolution that's been bubbling up just beneath the surface. And we're talking about a change so fundamental, it's not just about better computers, it's about reshaping reality itself. And the race to control it, oh, it's already well underway.
So, the big question on everyone's mind isn't really if another tech revolution is coming. It's what's it going to be? We're looking for something on the scale of the internet or the invention of the microchip. And it turns out the answer is hiding in the wonderfully strange world of quantum physics.
And hey, if you think this is just some far-off sci-fi dream, think again. The global bet has already been placed. We're talking more than 40 billion euros that governments and corporations have poured into developing quantum technologies. The starting gun has been fired, and the stakes could not be higher. Yeah, this isn't just some friendly competition in a lab. This is a new global race. You've got the world's major powers all jockeying for the top spot, each one desperate to be the first to master what could be the most powerful tools humanity has ever created.
And let's be really clear here. This isn't just about making your laptop faster. Not at all. This is a total paradigm shift. Quantum technology is poised to completely rewrite the rules for how we compute, how we communicate, and maybe even how we perceive the world around us.
Okay, so to really get your head around the massive scale of this revolution, we've got to start small. We have to look at the single most fundamental piece of the puzzle. We're leaving the world of simple bits behind and entering the age of the qubit.
All right, think about it this way. A classical bit, the thing that powers all of our technology right now, is basically just a light switch. It's either off, that's a 0, or it's on, that's a 1. Simple. But a quantum bit, a qubit, that's a whole different ballgame. The best analogy is a spinning coin. Before it lands, is it heads or tails? Well, it's kind of both, at the exact same time.
That spinning coin state has a name. It's called superposition. And this mind-bending ability to exist in multiple states all at once is the secret sauce. It's what gives the qubit its incredible power. Instead of checking one answer at a time, it can explore millions of possibilities simultaneously. And this is where things get, well, explosive. 10 regular bits can represent one number at a time. 10 qubits, they can represent over 1,000 states all at once. Now let's jump to 50 qubits. Suddenly you're representing over a quadrillion states. But here's the number that just breaks your brain. With just 300 qubits, you could hold more information at one time than there are atoms in the entire known universe. Just let that sink in. That's the staggering power we're talking about. So, okay, we've got this almost unimaginable power on the horizon. But what's the point? I mean, what does that actually mean for us in the real world? What kind of problems can this thing actually solve? Well, as researchers at Spain's National Research Council put it, the whole goal is to go after the problems that are just impossible for our current computers. The stuff that even today's biggest supercomputers would choke on.
Okay, take sustainability, for example. With a quantum computer, we could simulate molecules perfectly. That means we could design brand new, hyper-efficient materials for solar panels or create revolutionary new batteries. We could even invent chemical processes that literally suck pollution out of the air. It's about tackling climate change right down at the atomic level.
And it's the same story in medicine. Imagine being able to create a perfect digital twin of a complex protein that causes a disease like Alzheimer's or Parkinson's. We could test thousands of potential drugs on that virtual model, finding life-saving treatments in a fraction of the time it takes us today.
But, and this is a huge but, all this power creates a massive paradox, especially when it comes to cybersecurity. It's a real double-edged sword. On one hand, you could use quantum physics to create perfectly secure, totally unhackable communication. On the other hand, a powerful quantum computer could be a skeleton key, capable of breaking every single piece of encryption that protects our bank accounts, our data, and our national secrets.
And that high-stakes paradox is exactly why this whole thing has blown up into a major geopolitical issue. So let's take a look at the global map and see who's who in this quantum race. Right away, you can see there are 3 pretty different game plans. Over in the US, it's really being driven by the private sector. You've got the tech giants, Google, IBM, Microsoft, all battling it out. Then you have China, which has taken a top-down, state-controlled approach, pouring over 14 billion euros into a centralized national effort. And Europe? It's trying a more collaborative approach, pooling resources through its quantum flagship program to boost industries all across the continent. And if you want to see how that collaborative European model works on the ground, just zoom in on Spain. They've rolled out their first national strategy, And they're backing it up with an €800 million investment, all designed to build their own quantum muscle within that wider European network.
And that money is already creating a real, tangible ecosystem. I mean, Spain's already got more than 30 research groups hard at work, over 10 specialized startups popping up, and strong leadership from its top institutions. And here's the kicker. It's about to become home to Europe's most advanced quantum computer, which is a huge move to make Spain a central hub for the entire continent. But after all that hype, all that promise, and all that money, let's bring it back down to earth for a second. The quantum future isn't a sure thing. It's not guaranteed. There are some really big, really tricky hurdles that scientists are still trying to figure out how to jump over.
A recent survey of experts gives us a really clear picture of what those roadblocks look like. And while this data is from Spain, you hear these same things everywhere. According to them, the biggest barriers are a lack of funding and support and not having the right infrastructure in place. Right behind that are the massive technical challenges. These machines are incredibly hard to build and keep stable. And then there's a serious shortage of people who actually have the skills to work on them.
So what's a realistic timeline here? Well, right now, these quantum computers are basically experimental. They're powerful for sure, but they're also unstable and full of errors. But look ahead to 2030, and the consensus is we'll start seeing real practical quantum advantage in very specific areas, like chemistry or cryptography. Fast forward to 2040, and as the tech gets more mature, this could be a market worth nearly €100 billion.
Which brings us right back to that huge, central question that this technology forces us to ask. When this quantum leap finally happens, what will we have built? Will it be an unbreakable shield that protects our entire digital world? Or will we have forged an unstoppable spear, one that can pierce every defense we've ever made? The race to find out is happening as we speak.